Right, grade 11's the last main concept of this section is the area of a triangle. And so there is a new rule to use when you don't have a right angle triangle. Again, you could use it in a right angle triangle, but this is specifically, you can't use half base times height in a non-right angle triangle. All right, then after this, we will be moving on to more complex questions where you have more than one triangle in a picture, and when they throw in variables and x's and alphas and betas, what are we going to do then? So with the area of a triangle, though, it's super simple, it's super great. So let's get into it. All right, so the area of a triangle, you have known the area of a triangle as half base times height for quite a while now. So if in this case, let's say we had triangle ABC given to us here, right, and we've got side 4, side 7, and we've got the included angle between. If we were to drop a perpendicular, so this is leading into the proof of the area rule, and so if we were to drop a perpendicular, we would have right angle triangles, but we'd also have all our regular trig that we can work with. So if we take sine 47, it's going to be our h over our 4, opposite over our hypotenuse, h being the height, 4 being the side across from the right angle. So because we've put h in, let's keep it banked to one side. It will be equal to 4 sine 47. So now, if we were to look at the triangle ABC, we could take half of the base, which is 7, times the height, which is 8. So half base times height, because we have a perpendicular. As long as we've got that perpendicular height, then we can use our old formula. But we know our height is equal to 4 sine 47. And so half 7 times 4 sine 47 gives us the area of this triangle. We don't have our h anymore because that's what we constructed in. And we've got our area of our full triangle. So in this case, we have dropped a perpendicular. We have created a perpendicular triangle situation. Doesn't always have to be a right angle as a whole triangle, but there must be a perpendicular height. So you can even add in there half base times perpendicular height. Then we've manipulated, got a perpendicular height, and solved using sine is opposite over hypotenuse. So this forms the rule for the area rule. So the area of a triangle is half of the product of two of the sides and the sine of their included angle. So if you want the area of this triangle that's been given here, you don't need to drop a perpendicular. You don't need to do all that. That was just showing you how it came about. You can just take any of the angles you've been given. Now, this one's been shaded in, so you know that one has been given. Half of the side times the side that is trapping that included angle. Okay, so half of AB sine of the included angle. So let's have a look at the general proof on the next slide, and then we'll do some number examples. We'll come back to the proof in a second. So here is the proof of the area rule. You drop a perpendicular, so it must be a perpendicular height, and you find the height using a sine ratio. It doesn't matter which one you're working with, but we're going to work with angle C there. Stick with one sort of process that you have. So angle C, opposite over hypotenuse, right? That is going to be our sine of C is h over b. So get h by itself by multiplying the b across. And so using our previous rule, half base times height. What's our base here? Our base is a. What's our height? It's represented by b sine c. So that is the proof of the area rule. That's very straightforward. Okay, so let's have a look at the area. So you need two sides and the included angle in order to do this problem with the area rule. So finding the area, see we've got side, included angle between them. So the area of this triangle, PQR, is going to equal to half of 12,3, 6,1 sine of their included angle. It doesn't matter what order you have the sides in, because multiplication order does not make a difference. Please don't put cos 40. It is sine 40. The cosine rule could also be used here with two sides and an included angle, but not to find the area. That's only if you want to find a side or another angle. So in order to find the area, this is the only formula you can work with. And you need two sides and their included angle. And the answer to this will be 24,11 square units. Okay. Then find the area of the following. Again, let's check side, side, included angle. So our area of our triangle MKT is going to be half of side 1, side 2, sine of the included angle, which equals 23,27 square units. Right, so that's how simple the area rule is. The only time it's going to get complicated is if they don't give you side, angle, side, and you've got to work out some things in order to get that correct combination for the area rule, such as this one. So it says find the area of the following. They've given you two sides, but they have not given you an included angle. They've given you one on the side. So the included angle would have been angle B. So we've got to do a little playing around. Same thing here. They've given you two angles and only one side. So it's not angle that's included between two sides. So side, angle, side. We need to manipulate. We need to work some things out. Right, so let's have a look. In order to use the cosine rule, you'd either need three sides, which we don't have in question 3, or we'd need side included angle side, which we don't have. Otherwise, we could work out the area straight away. So we have to use the sine rule to start. There's my complete pair. There is my side, and it is opposite angle A. So we're going to have to work out angle A first, and then we can work out angle B using angles of a triangle, and then we'll have 10, 9, and the angle between them. So we have sine of angle A across from 10 is equal to the sine of 50 over 9. Have the complete side on the right-hand side. Have what you're looking for, top left, because then all you need to do is multiply that 10 across and shift sign in your calculator of that whole fraction and get your answer. So we have 58,34 degrees, so angle B must be 180 minus 58,34 minus 50 degrees, which gets us 71,66 degrees, angles of a triangle. So now that we have 71,66, we can work out the area of the triangle to be half of 10 times 9 times sine of the angle between them, sine of the included angle. Right, and that gets us 42,71 units squared, or square units. For the last one, same story. We have a completed side. And then let's see what else we have. We don't have an included angle. We don't have three sides. So we are definitely going to have to find that side over here, LK, because then what I'll have is I'll have this 15, I'll have LK, and I can easily find angle K by using angles of a triangle because I've been given the two other angles. So let's start with using the sine rule because I've got a complete pair. So I'm looking for LK across from its angle, and I've got 15 and then across from its angle. So LK is going to be 15 times sine 33 over sine 48. Pop it in your calculator and LK equals 10,99 units. So then now we have this situation where I've got 15, I've got 10,99, so I just need angle K to have side, included angle side. And so angle K is going to be 180 minus the 33 minus the 48, which is 99 degrees, angles of a triangle. So then we can work with our area of our triangle, LKN, is equal to half of my side 1, side 2, times sine of the angle between them. And that gets us 81,41 square units. All right, just a side note here. I'd just like to show you, if you go back to the idea of the very simple right angle triangles that you had, let's say this was 5 and this was 6, you would say the area here is half base times height. So what's the base? So half of 6 times 5, and that would be, so 3 times half of 6 is going to get you 3 times 5 is 15 square units. Now, if we were to take side included angle and actually call this, instead of half base times height, use it as half of side 1 times side 2 times sine of your included angle. Sine of 90 is a special angle to equal to 1. So you've actually always been using this, but you've always used a right angle. You've always used 90 degrees, and sine of 90 from this area rule is always 1. So you've just left it off. So it's the same process, except your half base times height doesn't need the sine part because it's always going to be sine 90 in a right angle situation. All right, so the only requirement that you, or the only situation that you can use this in, is 2 sides and the included angle. All right, so you can work on the area rule, and then you can wrap it up all together and practice all 3 rules in the mixed exercises.